Astrophysics is an incredibly rich field that has led to many discoveries within our own solar system, as well as the entirety of the universe. This pursuit of knowledge had to start somewhere, though, and that somewhere is our home planet Earth. Many facts about the Earth we take for granted, such as the Earth is indeed round, and that the Earth has a certain size. Let us first consider the roundness of Earth. Who discovered that the Earth is round? A common misconception is that Christopher Columbus sailed around the Earth to prove once and for all that the Earth is round and not flat. This is an outright lie, though, attributed to a biography of Columbus penned by Washington Irving. So who discovered that the Earth was round? It is well known that the ancient Greeks, including but not limited to Pythagoras, widely believed in the round Earth postulate and attributed the strength of the argument to common sense observations of the world around them. One great example is a lunar eclipse, in which during the entirety of the event, the shadow of the Earth cast upon the moon remains a circle. This would only be possible if the Earth were indeed round. But how can we test that the Earth is round? One easy testing experiment the ancients unwittingly performed is that if you watch a ship go out to sea, you will notice that the hull will disappear before the mast. But if then you ascend a hill quickly and look out, you will be able to see the hull again. This, of course, would only be possible if the Earth were round. Now, in addition to postulating that the Earth is round, someone must have worked out what the size of the Earth was. As it turns out, the ancient Greek Eratosthenes worked out the radius of the Earth to within 16% of its actual value, which is quite astonishing, and this is how he did it. For all intents and purposes, you can consider light incident on the Earth to be parallel since the Sun is so enormously far away from the Earth. With this assumption, along with the assumption that the Earth is round, all we need are two sundials directly north and south of each other. During the equinox, Eratosthenes knew that a sundial in Syene or Aswan would cast no shadow at noon. So in Alexandria, which he assumed to be perfectly north of Aswan, he measured the angle of that shadow that was cast by the sundial. The angle measured at Alexandria, depicted as point A here, is the same as the angle as measured from the center of the Earth between Aswan, point S here, and Alexandria. The distance, delta, between the two cities was determined by the time it took the soldiers to march between the cities with an assumed velocity. So the ratio of the arc length swept between the cities to the angular separation would have to be the same as the ratio of half the circumference of Earth to 180 degrees. Simple algebra then would give the radius of the Earth. Let us consider a separate experiment the ancients may have performed to test Eratosthenes' result of the radius of the Earth. Our test will draw on the horizon observation noted earlier. Our test simply consists of a person at sea watching a trireme go out to port. Greek triremes were the dreadnoughts of their day, able to destroy other ships with sheer speed and in a fixed battering ram. The oarsmen of these triremes were able to take the vessel to a cruising speed of 4 knots, with manpower alone. So, assuming that the crew rows at a constant speed, and the Earth is round, we can predict the time it will take for the hull of the ship to disappear. To calculate the horizon length, we just need to consider Pythagoras' theorem, with the right angle of the right triangle lying between the observer's feet and out to the horizon, D, with the hypotenuse of the right triangle going from the center of the Earth, extending out the radius of the Earth, and including the height of the ship above sea level. With our known values, this would give a distance of the horizon being 5.2 kilometers. Now, since we are assuming the ship to be traveling at constant speed, we can determine the time it would take for the hull to disappear with a given radius of the Earth. And this turns out to be 42 minutes with our given values. So you would simply have to sit and watch a ship go out to sea and time it. To confirm your result, if it's close to 42 minutes, the radius is probably pretty good. In reflection, it's amazing what the ancient Greeks were able to do with common sense and simple observations.